Hello everyone, Sarang this side, and in this video we're going to learn how to use OpenAPI Maven plugin to generate the WebFlux stub and the WebClient stub. So to explain this, I have created a simple microservice architecture where I have two microservices, and in the microservice A is the one where the user will make a request, and with the help of the generated WebFlux stub, the request will be received and it will be given to the business service, and the business service will make use of the generated WebClient stub, and that generated web client stub will call the microservice B. And once the microservice B gives the response, it will be taken by the generated web client stub, and the response will be given to the business service and back to the WebFlux stub and then to the user. So as you can see over here is the generated WebFlux stub and the generated web client stub are the one that will be generated using OpenAPI Maven plugin. So usually what we do is whenever we call the microservice or any of the microservices from one microservice, we write the web client code manually, or if we just write it in a Spring Boot application, we create a bean of web client and then call the other microservice. But in this video, we will learn that how we can even generate the web client stub. We will not write the web client code manually. We will generate using the OpenAPI Maven plugin, and then we will call the microservice B. So to generate the stub using OpenAPI Maven plugin, there is one prerequisite that you need to write your API specification in a spec file. So that is called OpenAPI specification file, correct? So that should be in YAML or JSON format. So once you give that file to the OpenAPI Maven plugin, the plugin will generate the corresponding stub for that. So in this case, the microservice A would have two specification files. One to generate the WebFlux stub, and another one is to generate the web client stub. So let's head to the IntelliJ to understand the process. Okay, so I have a very basic Spring Boot application over here, and here you can see that in the plugin section I have configured the OpenAPI generated Maven plugin, and inside that I have two execution. One execution is to generate the server stub, and another one is to generate the client stub. Okay, so in the server stub generation, I have given the input spec one YAML file. That name is api.yaml. As you can see, it's present under the project directory, under the resources folder, and under the OpenAPI folder. So that file will be given as an input to the OpenAPI generator, and using that file, the Maven plugin will generate the stub for us. Okay. So other configuration, if you can see here, is the generated name I have used over here is Spring, because I need to generate the controller layer. You can say a controller layer or a WebFlux stub. So here we can also generate the non-WebFlux stub by not adding this particular tag called reactive. So once you add this tag called reactive as true, then the controller, all the controllers will be a reactive controllers. And if you don't add this tag, then it will be a basic MVC controllers generated for you. And here a new tag got introduced recently because there are slight differences in a Spring Boot 3 version. So once you are using a Spring Boot 3 version, you need to add this tag so that the OpenAPI Maven plugin will understand that it's a Spring Boot 3 application and it will use Jakarta and not JavaX. So once you add all these tags under the generate server stub, you would see the WebFlux stub getting generated under the target folder. So I'll show you that. So, but before that, I will show you what's there inside the api.yaml file. So let's open this file, and over here you can see that I have configured the server information over here. So I'm saying that generate a stub which can listen to this host, localhost, and to this port 8080, and it would have one endpoint with the name weather/location. Okay, so this endpoint will receive a request which would have two properties, and one of the property is latitude and the longitude. Okay, so here you can just ignore this particular endpoint. We'll only focus on the first one, that is weather location. Okay, so once the user sends this request which has latitude and the longitude, okay, that request will be received by the stub, and that will be generated by OpenAPI Maven plugin, and that using that generated stub, we will get this latitude and the longitude from the request, and then we can just add those properties into a business service and write the business logic. Okay, so this is about the request, and the response we will get it from the client.yaml file. So I will also show you what is this client.yaml file, but this is the specification for generating the WebFlux stub. Okay, So let's go and understand about the generation of the client stub over here. So here what I've done here is like there is an input spec again. So this is now a different specification or execution. So this execution was for generating the WebFlux stub, and the second execution is to generate the client stub. Okay. So here I have given an input spec where the file name is now client.yaml. Okay, and the generated name is Java over here. There was Spring. Here it's a Java, and I'm just saying that generate the APIs and model into the specific packages. As you can see here, I have written client, and there it's a server. And then I'm just ignoring the text file, so I'm just saying that don't generate the text file. So I have just named it as false over here, and under the Java generated name, I have mentioned that to use a web client library over here. So it will generate the web client stuff for us. Okay, and since it's a Spring Boot 3 application, so we have to inform the plugin to use this Jakarta EE, not Java X. Okay, so once we have configured this, you will just look at the client.yaml as well before we generate the stub. And inside this client.yaml, we have this weather info, and that weather info is under this host and the port, that is 4010. So what we are telling to the OpenAPI Maven plugin is, please generate a web client stuff for us so that we can call this localhost 4010/weather info endpoint. Okay, so since we are creating a client, so the client should know to which server it should reach out to get a response. Okay, so here we are telling reach out to this localhost 4010, but in the case of API.yaml, we are saying that listen to this particular port and host and port to get the request from the users. But here in the client.yaml, we are saying that reach out to this particular host and port so that we get a response from a different microservice. So as you can see here is I'm also generating a web client stub. So for that I need a specification file. So this is the file for the web client. Okay, so here in the query param I am getting latitude and the longitude. As you can see here in the parameter section, I have configured that in I need a query. Okay, so there are also path params and headers, but I don't need those, but I need a query. So I have just mentioned it over here that I need a query of type latitude and the longitude, and this information I'll get it from the users. Okay, and the response we will give back as a weather info that would have temperature and the conditions. Okay, and this response we will use it under our API, which will be called by the user. So I'm just referencing that object from that file so that we reuse the response that has been given by the other microservices. Okay, so this API.yaml will be used to generate the WebFlux stub, and this client.yaml will be used to generate the web client stub. Okay, so here in this stub we are saying listen to the specific request of the users, and here we are saying call the other microservices. Okay, so in this case there is a microservice B, and we will try to get the weather information from this service. Okay, so I have written the specification file for this, and there is a configuration done for the OpenAPI Maven plugin, so that we just have to compile the project, and under the target folder we will generate all the stuff would be generated for us. But before that I will also show you the dependencies that I have used in this project. So since it's a reactive application, I have used Spring Boot Starter WebFlux and a few Swagger dependencies to render the Swagger UI. And since I'm using the Spring Boot 3, so I have used Jakarta dependencies over here. And here the Jackson and the Lombok is for faster development. And if you're using Mac, you need to add this Netty Resolver DNS native Mac OS. So I've added that also. Okay, so once you have all this information in your pom.xml, you're good to generate this stuff. So what I'm going to do over here is I'll head towards the terminal, and I'm going to run this command mvm clean compile. Okay, now you have to go to the target folder, and under the generated source there is an OpenAPI folder. Under that you will see src java and com OpenAPI demo, and here you would see two folders, client and server. So all the web client code has been generated under the client folder, and all the WebFlux code has been generated under the server folder. And here you would see API and the models. And this information about generation, like where to generate this classes, I have given under this configuration only of OpenAPI. So as you can see, for the servers, generate all the server API and models under this package called server. And for the client, I have written over here for APIs and model generate all the code under the client folder. Okay, so once you have all this stuff generated for you, what you can do is you can just start your microservice. So I'll just go and click on that button, and as you can see, the netty got started on the port 8080 because I have written over here is I'll be listening to this localhost 8080. So that's what it got started. So I'll go to one of the client called RESTful box. So it's a one of the plugin that I have installed in the IntelliJ IDE to just call the APIs. So here what I'm going to do is I'm going to call this microservice 8080 API weather slash location, and in the body I'm going to add latitude, and this should be of type number. As you can see over here in the request, I did latitude and the longitude, so I will just write this information over here and I will send it to the microservice. Hang on for a second. Okay, so let's look at this. It's a post API, so we have this written over here. It's a post and it's an HTTP localhost 8080 API weather location. Yep, it's the right one. So let's again hit the API and just to check the response. Okay, the request has been made, but we got a response here as 501 not implemented, and the reason here is if we just go to the server folder, under that there is a weather API delegate, right? So here the stub has generated a default method for us with the name called weather by location, and it has referred this name from this spec file where there is an operation name called weather by location. So it has implemented this method, and it's a default one, and inside that there is a default HTTP status called not implemented, and that's what we are getting in the response. So in order to write a business logic, we have to implement this particular delegate interface. So as you can see over here is we have generated the WebFlux stub. It has given us the default method implementation, but we have to override and write it under the business service. So let's start creating the business service now. So what I'm going to do is I'm going to create one package with the name delegate, and I'm going to create a file called weather API delegate impl. Okay, and I will just click this don't ask again, and I will just write implements weather API delegate, and here I will implement the weather by location over here. Okay, so now let's head back to the diagram, and as you can see, the business service will call the or will make use of the generated web client stub to call the microservice B. So now we have to kind of import whatever got generated in the target folder for the client. So this API, under the API we have this weather info API. So it has one of the class called API client, and under that there is a web client. Okay, so this web client will be of default one. We just have to we don't have to do anything with that. We just have to import this weather info API class and have to call this method weather info, which takes latitude and the longitude as an input. Okay, so let's go to the class, and I'll write private final weather API info client, and I will just create one constructor over here. Okay, and here I will say new weather info API. Okay, so after writing this, we will make use of the request that is sent by the user. I will write it as location dot flat map, and then weather info API client dot weather info, and from here I will take one of the parameter called LOC, and here I will write LOC dot get latitude, LOC dot get longitude, and this line over here will call the another microservice which is listening to host called localhost and at the port 4010. But right now I don't have that microservice running in my machine. So what I'm going to do is I'm going to create a mock server, and the request will go to that mock server because the mock server will listen to this localhost 4010 and it will expose this weather info endpoint. So we will do that using another tool called Prism. But first, let's write a logic of sending a request to another microservice. So that's what we are doing over here. Okay, so this weather info will invoke the API of another microservice, and it will give a response which will be wrapped under mono, and it will be of type weather info. Correct? So I have written under flat map, so I'll get weather info over here, and I will map it over here, and I'll just write it as a remote response. Okay, so now I'm going to create by using this remote response, I'm going to create the object of weather info. Okay, so here it is, and I will make use of the getter setter. I will get in response temperature, right? So I'll get remote response dot get temperature and response dot set condition, remote response dot get condition, and I'm gonna wrap this response into the response entity dot okay, and I'll just write it here response, and then I will write a return over here. Okay, so let's see what is the error that we are getting. Okay, I'm supposed to send this weather by location response, so that's what we have sent it over here. Okay, so this was it. So what would happen now whenever the user is sending a request that would be will be listened by this WebFlux stub, and we have overridden one of the method called weather by location. So the WebFlux stub will send the request to this business service, and the business service name is this weather API delegate IMPL. So let me annotate this with the service so that it creates a bean for it. And the business service makes use of the generated web client stub. So this is one of the stub called weather info API, and using that we are calling the microservice B. Okay, and that microservice B requires two query parameters, that is latitude and the longitude, and all this information, as you know, that we have defined under the client.yaml, that it needs this two information, right? And based on this information in the specification file, it has created a method called weather info, and it has also asking us to add this to latitude and longitude, and that is all because we have configured all this information in the client.yaml. Okay, so here we are calling another microservice, and we'll get a response, and that will come under the remote response, and then we are creating a response for the API called weather by location. So once that is done, so now only one thing is remaining over here is we don't have microservice B now, okay, which is listening to the host localhost 4010. So what I'm going to do is I'm going to create a mock server with the help of the tool called Prism. Okay, but before that, let's execute this code and understand what are the things that we are lacking over here. So we'll see if we get any errors apart from the connection refuse. So let's restart this server. So previously we were getting 501 not implemented, but now let's hit that and understand what is the error that we are getting. So now we are getting the connection refused localhost 4010 because there is no microservice which is exposing this post and host, right? So now we have to create we can even either create a new microservice or we can create a mock server, but in this case I'm going to create a mock server. Okay, now I'm going to make use of the tool called Prism, as I said. So what I have done is I have created a Docker file for it, so a Docker compose file which will fetch the Prism image from the Docker hub, and I'm just executing one of the command which will be starting the Prism server, okay, at the host localhost, and it will give the dynamic information of the response by referring this client.yaml. Okay, so the input to this Prism is nothing but one of the OpenAPI spec file. So since I want to generate a mock server which can expose this weather info endpoint, so I'm referring to this client.yaml in this Docker file. As you can see over here is I'm referring to this client.yaml, and I'm creating a volume so that all the files under the OpenAPI gets into the Docker container, and then using this command and referring to the client.yaml, so that Prism can read this client.yaml specification file and create a mock server for us, which can listen to this port 4010. So that's it. So now what I'm going to do is I'm going to start the Docker, and let's see whether we're able to start the mock server or not. So let's wait for the Docker to start. Okay, so I already have this Spotlight Prism image over here. So whenever I start the Docker compose command, it will reuse that image. But if you don't have the image, it will download it for you. So first, what I'm going to do is I'm going to stop the microservice A, and I'm going to create a mock microservice B. That's what you can understand from this. And mock.yaml, I'm going to press up. So here you can see the logs attaching to mock weather servers, right? Because I have written over here mock server, so it has referred to that name. So it is now awaiting starting the Prism. Okay, and it has started listening on the port 4010 to the host, localhost, right? And it also says that it is exposing one of the API called weather info, which accept latitude and longitude, as you can see over here. So you can also verify this by going into this Docker desktop. You can click on this on that container, running container, and then you can click on the files, and under the app you can see this two file, API YAML client.yaml, right? And since we have configured it to expose the API in the client.yaml, so it has exposed all the APIs which is present under the client.yaml. Okay, so after doing this, what we can do is just start our microservice and then hit the endpoint API weather location with the body having a latitude and longitude. So let's send the information. So we got back a dummy response from the Prism mock server. As you can see, it has given us the dummy temperature and the condition. There is the response given by the mock server, and we are also we are leveraging this response. So we are leveraging this response to our microservice A, and this response has been given to the user. So I am the user now sending this, let's say latitude and longitude 1, 2, 3, 4, 5, 6. And I'm sending this information, but let's also add the log so that we understand it's coming from the microservice B. So I'll make use of the SLF4j over here, and I will write a log statement, log.info. I'll just write here as remote response, and then here I'm gonna write remote response. Okay, so I'll again restart these microservice. Okay, so now the request will come to this service, and it will reach out the microservice B, and we are logging the response from that microservice B. Okay, as you can see over here is the remote response we got back is temperature, which is ending with 57. Yeah, it is this one, and the condition is EU. So it is just a dummy data we have asked the Prism server to emit. So that's what it emitting. So like every time you will see this data is getting changed whenever we call, right? Now the temperature and conditions are different now. So this was it. So I hope you understood about this OpenAPI Maven plugin, and it has helped us a lot. So actually, since it's generating the stuff for us, it is making the developer lives easy, because whenever we create a microservice or REST API, we have to write a lot of boilerplate code, and that code now taken care by the OpenAPI Maven plugin. So we just have to configure that plugin with the right specification file, and it will generate code for us. So we just have to leverage that code in our business services, and then we are good to go. So this was about that. So I hope you enjoyed the video, and if you're new to the channel, subscribe, like, and share with your friends, and I'll see you in the next video. Thanks.